Good afternoon. Today we're going to talk about nuclear explosions, and we're going to focus on a concept called fission, because the first nuclear bombs were fission bombs. Um, Fission is the splitting of the nucleus into two smaller nuclei. Now, when this happens in a critical mass, what is caused is a chain reaction. Now, a chain reaction in critical mass can sustain itself, and so that action of splitting one nucleus into smaller daughter nucleus or nuclei um, continues that proliferation. I have a bit of a rudimentary drawing, as you can see here. This neutron hits this nucleus here, and then it splits off, and these throw more emitted particles that split off, and this chain reaction is part of that uncontrolled explosion. In the fission bomb, in order to set off the chain reaction for a fission bomb, you need an unstable nucleus. And what is usually utilized is uranium-235. Now, with those emitted particles that happen from that chain reaction and the fission, there are several things that can be damaging to humans, not only in that initial explosion, with everything from the shock wave to thermal energy to radiation exposure and the intense immediate aspect of that, but those emitted particles can and continuing radioactivity can continue to affect people long after a nuclear explosion has happened. But what are these emitted particles, and what role do they play as far as damage is concerned? We have the alpha particles, which are not able to penetrate human skin. So they are only really dangerous if they're emitted inside the human body. You have beta particles that are much more fast moving, and these fast moving particles can move through millimeters of wood, even a certain amount of thickness of aluminum, and this will create something similar to a sunburn, where the larger or more damaging aspect of emitted particles or slash energy really is gamma radiation. Gamma rays are energy beams that can move through the human body, actually move through several layers of concrete, and this can cause immediate death, sickness, and then lingering effects later on down the road, such as cancers and things of that nature. Another effect of the explosion, nuclear explosion caused by the nuclear bomb, is what's called nuclear fallout. Now, fallout is where the radioactive material has been thrown into the atmosphere and then comes and rains down, essentially drenching the area and other areas with that radioactivity. But how does the atomic bomb work? Now that we have those concepts in mind, and we kind of know what goes on afterwards, let's backtrack a little bit and see how it works. Well, we can't specifically say that how to build a nuclear bomb, because it's very top secret as far as preventing nuclear proliferation. However, we can go over the larger concepts, and that's combining the things that we have learned. Now, we use a chemical, or they use a chemical process, or just a regular explosion, to be able to send that initial neutron into the uranium-235, which is very unstable. And when that hits, that is what causes that chain reaction. That chain reaction at critical mass becomes uncontrolled fission, and that is how the atomic bomb works. And that is all I have for you today. Thank you.